I ask teachers from CB, you know, when our students go to CB and take algebra 2, I ask what sort of things do they need to really know. They all said, oh, they always make silly mistake on exponents. Okay, so that's what we need to work on, and that's what we're going to work on today. So for example, if I have 5 to the 4th power, okay, what's it mean when I have 5 to the 4th power? Raise your hand. Yeah. Exactly. It means you multiply 5 how many times?
4 times.
4 times. And does anybody know, so we could actually write down, does anybody know offhand what this equals to? What's 5?
Oh.
Yes.
Wait. No, never mind.
It's correct. It's 625 because it's 25 times 25. Isn't that right? Okay. So that's what we got there. Now, who remembers? So for example, if I have like b to the nth power, what do we call this n? There's a name for that n. Anybody know what that n is called? Yes, sir. Exponent is correct. Then what do we call that number like down there? Not the exponent, but oh, okay. Yes, sir. Power. No, the whole thing is called power. Yes, base is correct. That's why I used letter b. Okay, so, right. So you have this base b. You multiply, you know, how many exponent, whatever the exponent says, you multiply b that number of times, right? So if exponent is 10, how many times would you be multiplying the base? 10 times. Does it mean 10 times b? No, it means b times b times b, 10 of b's, right? That's why I wrote down n times. And of course you have to multiply. Okay, sometimes, not too many times. People think you have to add or something. No. The operation between each of these factors is multiplication, right? So p n times. And when we write b to the n power, we call that some sort of form. Does anybody know what form this is called? Like 5 to the n, 5 to the 3rd power, or x to the 5th power. Cameron? Exponential form is correct. Very good. So when you write this down, sometimes they call it power. It's called exponential form. When you write b to the nth power or x to the 5th power or whatever, you know, 5 to the 3rd times 7 to the 8th power or something, you know, exponential form. Okay. Does that make sense? So now I want you to, there's 3 things I would like to be careful of when you deal with these exponential form. First one is if I have something like this. Hold on. Sorry, be careful. If I have 2 to the 4th power, what's it mean? Raise your hand. Yes, sir.
2 times, 2 times, 2 times.
Which gives you? Yes? 16. This doesn't happen that much. Sometimes I do see this happen. Like people write 8 as the answer. Do you think why people do that? Why do you think people write? Yeah, Laura? Yeah, they just look at 2 and 4 and they multiply. Would that be right? No, so I don't see that a lot. But just be careful. It's not 8, okay? It doesn't mean 2 times 4. Also, this one I see a lot happening. Something like this. For example, 2 to the 3rd power versus, with the parentheses around 2x. No, it says 2x to the 3rd versus 2x in parentheses to the 3rd power. This is actually the thing that people mess up a lot. Madeline, do you see what the difference is? Exactly right. Without the parentheses, the base for this exponent 3 is only the x. You're right. What about the one with the parentheses around it? The base for this exponent 3 this time is, Anaish? Yes, exactly right. So in other words, the base for that is 2x, not just x, just like you guys said, Marilyn and Anais. Yes, question?
So for the first one, 2x to the 3rd without any parentheses, it's like 2 times x times x.
Exactly. That's what I'm going to write, actually. And as you can see, the other one is 2x times 2x times 2x. You're right. And of course, the 2x to the third power, we can't really do much. That's exactly what it is. What about 2x in parentheses to the third power? Thomas, can you see? Sorry, I can move it up. What does that become? 2x times 2x times 2x. That is simply 8x to the third power. Yeah, that's not 8x. It would be wrong. 8x to the third power. Do you guys see the difference? Okay. So as you can see, even though they look very similar, like 2x to the third and then 2x with parentheses to the third, they mean very different thing, isn't it? And I heard this math teacher explaining this to students. I think I kind of like that too. You see this exponent? So to explain why this happens is the exponent. Do you remember?
Yeah, he's like small eye.
Yeah. So well, not it's because the number is really small. It only sees the one right next to it. Does that make sense? So this 3, this exponent 3, only sees whatever is next to it. What does it see? That one next to it, x. So it only sees, it does not see 2 at all. You see what I mean? Because the number is really small. You can think of it that way. So that's why it's 2 times x times x. Here, what does that exponent 3 see? What's right next to the exponent 3? It sees the parentheses. So it knows to multiply that whole base, right? 2x 3 times. Does that make sense? Okay, so you could think of it that way if you like. Okay. Any question? Okay, so this is for a lot of you. Say it's very trivial stuff. This is very very straightforward. It's review really, isn't it? Another thing that I see a lot is something like this. I put a star there. That's a star, even though it doesn't look like it. Okay, so then what is the difference between -3 to the second power versus -3 in parentheses to the second power? Don't we get the same answer? No? You're right. That's why I put a star on this. Caroline, why do you think we don't get the same answer?
Because in the first one, the 2 only sees the 3 and not the negative. So you do negative times 3 times 3.
Exactly right. The first expression, the exponent 2, does not see the negative sign, does it? It only sees the 3. Whereas the other one, when there's a parenthesis around -3, guess what the exponent sees? It sees the -2. So you could think of this as like -1 times 3 times 3. Did I say -2? I'm sorry. I meant -3. So it's -1 times 3 times 3. Whereas the other one, it is what? -3 times -3. So guess what? What does the first expression become? Raise your hand. Yes. 1 person, 2, 3, 4, 5 people see it? Yes. What do you think? Sarah, what does the first expression become? -9. What about the second expression? Tali? +9. You see how it's very different? Okay? Even though they look very similar, you have to be really careful. Does that make sense, guys? So remember that exponent only sees whatever that's next to it. It doesn't see anything far, unless there's a parenthesis. Some of the students said, oh, it's like a glass. Glasses, it's wearing glasses. Parentheses, like, never mind. Okay, so maybe, like glasses, like it's wearing glasses and it sees it. So that's something that you should be careful of, okay? Are we good? All right, may I move on? Okay, good. All right, let's move on to the next example. Okay, so next example is, this is something that you may see on tonight's homework, okay? They're going to ask you to do something like this. They're going to say, write this expression, -4 times r times s times 2 times r times s times r, in exponential form. And as you can see why you don't want to leave it that way. It's very long. There's a way to write this a lot more simpler using exponential form. So, does anybody see? No. Does anybody see what we could do on this so that we could write this in exponential form? Laura? Put the variables together. Put the what? Numbers together and put the variables. Oh, there are 2 types. There's r and s. So put them separated like that, right? What property am I using when I'm changing the order there, like that? Who have an idea? Thomas? Commutative property. Now, what if I am grouping them with just numbers, just the letter r's, just letter s's? What property is that? After I use the commutative property to rearrange them, Madeline? Associative property. So go ahead, everybody, try. What would you do if you? So this is the whole sort of work I want to see. Where I know that some of you could do this in your head, but can you use the commutative property along with the associative property to write this as a exponential form? I will do something like this. You know what I'm talking about here? I put the numbers together, group them, r's together and group them, s's together and group them. And I realize this is a very simple example, but do you think you're gonna get all these simple ones every time? No. Okay, so I'm showing you how to do that on a simple one, so that when you get something more, you could use the same rules. So, Kyle, what does it become when you simplify this now? You probably just won't want to leave it this way because they want in exponential form. So, what would this be?
Negative 8s to the second power r to the third power.
Yeah, I wrote r first because r comes first in alphabetical order, but doesn't matter. Okay, does that make sense? Any question? Kobe?
No.
Oh, okay, there you had your hand up. So that's pretty straightforward. Okay. Let's look at second example. The second example is they get a little bit creative. Rather than just giving you guys some expressions, they ask you to do something like this. Find the area of the rectangle. And they tell you the length and width in terms of some variable expressions. So go ahead and write this down. So Harrison, what should I start with? If they ask us to find the area of a rectangle?
We should use the formula.
Formula, exactly right. Harrison, do you know the formula for the area of a rectangle?
It's area the length times width.
Yeah, area is equal to length times width. Okay. And so in place of length and width, what am I going to substitute in there? Yeah, sure.
Length is 5y, width is 2y.
Width is really 5y, you know, going left. Doesn't matter. I mean, you could, but yeah, usually the width is from left to right and then length is. So yeah, you're right. I plug it in, 2y and 5y there. Okay. And so, yeah, what's the answer?
10y squared.
10y squared. That's it. That's all they want. And of course, they're not going to give you these simple ones. They're going to give you some other ones, but you get the idea, right? Of course, if there were some units, you should write unit square. Remember, like if it's meters, you write meter square. If it's feet, feet square, and so forth. So I wrote down unit square there. Okay? Pretty straightforward. Yeah, nothing. It's all really review. Just reminding you, you know, how to write things in exponential form. Okay? Let's go to then. May I go to example 3? All right. Okay. Example 3 is, it says to evaluate the expression. Oh, who remembers what they mean by evaluate, first of all? How is that different than simplifying? Evaluate. Because if it was just simplifying, they would just say that. When they say evaluate some expressions, how is that different? What are they basically asking you to do? Yeah. No, you don't solve expressions, you simplify expressions, right? So the expression you don't solve, what do they mean by evaluate? Yes? Plug in, that's exactly right. So they give you something like this. It says evaluate this expression if m is equal to -2, and you have two expressions. They look very similar. Do you think we're going to get same answers for both of these?
No.
No, I don't think so. Go ahead. You guys try. I'll give you some time for you to think about. So who can tell me then what to do for A? By the way, when you evaluate, I ask you to use parentheses. Okay, who can tell me? Christine, tell me what to write. For the first expression, it'll be what? Huh? That's right. And when you do that, what do you get? There you go. Ollie? So, Kristen is correct. This is what we get. Now, you see that -3 is for the -2 only. So, what does that become, Nelly? Yeah, that's -8. Why is it -8? Isn't it +8? -2 times -2 times -2. No? Yeah, Cameron?
When you put like a negative to an odd power, So it's gonna be negative.
Exactly.
Which an even power, so